Your screen sharing. I'm just going to assume that that little red dot means I'm recording. So good morning. Thank you for dropping by this code along in Python for PythonBytes. And our goal today is to write a very, very simple adventure program. And the objective is to review some basic ideas in Python and tie them together in such a way that at the end we have a game that we can share with our friends. So my game is called Adventure, and when we're done with this, I will post the link to the game on Slack, and I will also post this video, if it records properly, to YouTube, and I'll put the link to that on Slack, so everything will be findable. So if you miss something here, that should be something that you can catch up on. And let's go over now to, without further ado, two things: the approach to the program that we want to take, and then the tools that we're going to need. So my approach is like this. I have an idea about an adventure that I'd like my friends to go through. And so in each case, it's going to be a series of puzzles. And each puzzle is going to be kind of self-contained. So there's not going to be a lot of running around from one room to another. It's going to be very linear, which means we solve one puzzle, we move on to the next one. And that's what I mean by it's a simple adventure game. A more complicated adventure game has two features that we won't cover today. The first one is, like, if you're exploring, let's say, a haunted house, you can move around from one room to the other. And as long as you're careful to avoid traps, you can go back again. And the second thing that a more complicated game will tend to feature is an inventory, which is a list of the things that you are carrying. And you can check that list at any time. And you can maybe pull something out of your inventory, like pulling a paper clip out of your pocket, and use that on some new puzzle, like let's say you want to use it to pick a lock. So we're not going to do that today, but there's lots of stuff that we can do with the simple version that we're working with. So the programming philosophy is that we're going to ask the player, what do you do, once we describe what's going on. And what we're looking for is for them to come up with a key set of words. So we're not going to try and interpret the English language, but rather we're just going to look for a particular response word in what they say that indicates they're on the right track. And for us, that's going to be good enough. And we'll say, congratulations, you figured it out. Let's move on to the next puzzle. Okay. So the way that we keep asking that question over and over again is we have a loop. And the loop keeps on asking and asking the same question, what do you do, until the right answer comes in. So that way, the way that we're going to set up that loop is using a while loop. And the while loop is going to be an infinite while loop that will never stop. So that implies that when the player gets the right answer, we have to have some way of falling out of the while loop. So this gets back to flow of control in a program. And the flow of control in a loop goes around and around and around until you have some way of escaping the loop. So look for that. We're also going to use a coin toss to choose between two possible things to say. So for that, we're going to use the random integer, or randint, function. And that randint function is built into the random library. So we're going to have to import that. And then we're going to need to, oh, by the way, to escape from the infinite loop, we need the term break, B-R-E-A-K. Okay, so obviously we're going to need to use input, but then after we get input, we're going to use two special functions that are associated, first of all, with a string, and then secondly with a string also. And those two special functions are called lower, which converts a string to lowercase, and split, which converts a string into a list. So the split is going to take some explanation, and we'll get to that as we go. But the lowercase, you can imagine, is very straightforward. It just simply takes a string that might have uppercase letters and turns them all into lowercase letters. And this is useful in case the player enters the right word, but maybe they capitalize it because it's the beginning of the sentence. And we don't care whether it's capitalized or not, so we're just going to convert everything to lowercase. Okay. Let's see, the last thing we'll need is the idea of a list, and the Python keyword in, which is spelled I-N, which asks the logical question whether something is in a particular list. So a list is exactly what it sounds like. It's a bunch of things that are separate from each other. And in simply says, is anywhere in the list, is this thing that I'm interested in that list? Okay, and if it's in there, then it returns true. So that's the logic. Okay, without further ado, let us begin. The order of things is always first the imports, and then we define functions, and then we have our main program. So you'll notice that these are just notes that I'm writing in English. I have a bunch of notes up above too that I already wrote that listed out the things that I just mentioned. And we're going to need to import. Oh, one other thing I forgot we're going to need is time so that we can put dramatic pauses into our narrative. So that's the sleep functions, and that's part of the time library. So we're going to import the time library, but I'm going to be tricky, and I'm actually just going to get the sleep function from the time library. So I'm going to say from time library import sleep, like that. So now I can write down sleep of 3, and that will pause the program for 3 seconds. Okay, the other thing that I need is, I mentioned I need random integers. So I will say from random import randint. And we'll use this really quickly, really soon here, and then we'll get it out of the way. That'll be the end of the random part. Okay. So I'm going to scroll down a little bit here. And I'm going to define my function to be what the program says to the player when the player makes a guess, but the guess doesn't turn out to be the right guess. So what we want to do is we want to say something to the player that makes it sound like we are the programmer. We have been listening to what they said, but it doesn't do any good to do what they just suggested. Or maybe we didn't quite understand what they meant. So here's what I'm going to write. I'm going to call this function say dunno, which means I don't know. Okay, so the program is going to be saying to the player, I don't know what to do. First thing we're going to do is we're going to print a blank line. And then we're going to toss a coin. And we're going to do this by creating a variable called coin toss. And that's going to be equal to randint. And randint takes 2 arguments, the low end and the high end of the random integers that you generate. So I'm going to say it's going to either be a 1 or a 2. Okay, so it's like we're going to flip a coin, and the coin is going to put a 1 or a 2 in coin toss. And if that happens to be a 1, so if coin toss is 1, then we're going to print, gosh, I am afraid I do not know how to do that. Sorry. However, if the coin toss was a 2, then we need an else statement for what happens when coin toss is not 1. And now we're going to print that does not seem to help. So that's 2 things that we can say. We could make 3 or 4 different things here and randomly choose between them. But right now I'm just choosing between 2 responses to make us sound like we're kind of really paying close attention. And now we're going to do a little sleep, time.sleep. Oops, no, we don't need time dot. We can just say sleep. Sleep 1. And then we're going to print a blank line, and we're going to print, how about we try again? Then we're going to print another blank line, and then this is going to return. And this is a function that we have defined. When we run the program, it will not run. It will not run because nobody has ever actually called this function in this program yet. So somewhere down here, for this to run, we would have to say dunno, and that calls the function, and then the function will run. But until we write down say dunno in our code, this is never going to run. Okay, so now we have our functions and our imports, and we're left with just writing our adventure. So this is going to be the structure of the adventure. I'm going to write it out for you. What we're going to do is have our introduction. And by the way, this is what I always advocate, is writing on a piece of paper with a pencil when you're writing code. I can't do that in this presentation, but if you can do that, get a piece of paper out and a pencil and write your code on a piece of paper before you try and write onto the keyboard, because it'll be less distracting to have all these strange pixels in the way. Okay, so we're going to write an introduction. And then we're going to say while true. And then we're going to say ask for what the player does. If they get the right answer, break. And then say some more stuff about what happens. And then while true, exactly the same thing. Ask for what the player does. If they get it right, break. Say some more stuff. And then finally, print, congratulations, you win the game. Thank you for playing. Put a blank line at the beginning and at the end of that. Okay. So that's our entire program. But of course, if I tried to click the run button right now, this would not work. Why would it not work? Because all of these lines of code are just me writing in English for my own benefit for planning purposes. They are not written in Python. They were not written in proper Python. It's a little bit of Python. The only code in here that's written properly is these 3 print statements at the end. So what's good about having these print statements at the end is that it's a good test for when we are testing our program, because I don't want to try and write this entire program in one go. Instead, what I want to do is write it in stages, okay? So I'm going to start off with the introduction, and then the rest of this stuff, I'm going to comment it out. So it's waiting for me to come back to it as my outline. It's like writing a paper for a class, for an English class, say, composition class. So that's what we have here. We have an outline and we have the word introduction. So let's start with our introduction. So this is the part of the program that's going to introduce the player to the game. We're going to start with a blank line, print, and then we're going to say, print, welcome to the adventure. Print. Oops, sorry, blank line. And now we'll put in a little sleep. We'll just sleep for 1 second while they notice there's a pause. Then we're going to do a countdown. Print. We will start in print. 3. Oops. Sleep 1. So what I'm going to do is I'm going to do a countdown. It sleeps 1 second in between each statement. 2. Sleep 1. Print 1. Sleep 1. Print. Begin. Doop. I like blank lines. Print. You are walking through a vast forest of leafy trees. Then we'll put a little sleep in here to make it more dramatic. Sleep 1. You have been wandering, lost for days. Sleep 1. Okay, that's it. That's my introduction. It's very simple. And I should warn you that I have a very, very, very poor sense of humor. And so the first puzzle is going to be a silly joke to solve, is a silly joke. That's going to be okay. But let's make sure that this works first before we try and do the next part of the program. So I try and write something small that I'm pretty sure will work, and then I run it, And if it works, then great, I can move on to the next part. But if it doesn't work, then I have to debug it. So I'm going to run it. It says, welcome to the adventure. We will start in 3, 2, 1, begin. You are walking through a vast forest of leafy trees. You have been wandering lost for days. Congratulations, you win the game. Thank you for playing. So everything worked as desired, but I didn't like the delays in between those print statements, so I'm going to make them a little bit longer. So I'm going to have the player wait for 2.5 seconds and 2 seconds. Now I'm going to test it again. We will start in 3, 2, 1, begin. You are walking through a vast forest of leafy trees. You have been wandering lost for days. Congratulations, you win the game. Okay, that feels a little better. Now, because we're going to be running this code a lot, I'm going to comment out my sleeps so that I don't have to wait for a total of like 7 seconds every time I want to see if the next part of my program is running properly. So you'll see I'm putting in comments up here. This is a common programming practice. If something takes a while and you want that there for player effect, you can comment it out while you're still working on your main program. Okay, so with that, I say run, and it goes bloop, and everything's there. Fantastic. Now we get to move on to the next block of code, which is this while loop, and that's the first part. Okay, so I'm going to uncomment the while true. And the while true is more or less in good shape, except that it doesn't need those parentheses. And if I can remove parentheses, I will to make it simpler. So while true means do everything in the block of code below over and over again forever. As long as true is true, and true is always true, it'll just keep on doing this code. So we're going to ask for what the player does, and if they get it right, then we use a break statement to fall out of this loop. Oops. 1, 2. I think we can indent 2. So here we go. First, we'll print a blank line. Then we'll use an input statement to get the player's reply. Reply, that's what the player says, is equal to input. How do you escape from the leafy forest? We'll put a space at the end of that because it'll make it read a little better. Okay. And now, because I'm in debugging frame of mind, I'm just simply going to print the reply string. And of course, it's going to go looping around and it's going to ask me again and again and again. So let's test to make sure that that happens. So I run it. How do you escape from the leafy forest? I'm going to type run away. How do you escape from the leafy forest? I quit. How do you escape from the leafy forest? I don't know. I don't know. Okay, so every time it prints back what we said. So here it says, I don't know, because that's what I entered. It says quit, it says run away. So we know that the reply variable over here is correctly getting my input. So I'm going to stop the program. And now we're going to do some more stuff with the reply. So the first thing we're going to do is we're going to convert the reply into lowercase. So we're going to say a new variable, reply lower, equals, and this is how you use the lowercase function. It's actually attached to a string variable. So it's built in like this, reply.lower. And now that we've done that, we can print our new variable, reply_lower. Reply_lower. So we're making progress to where we can actually turn all the words that I enter as the player into a list. So before I run this, I'm going to show you what that list might look like. So let's suppose that I type in run away. Okay, so I type in this string and we get reply is equal to run away. Now I run reply lower equals reply.lower. And so what's that going to turn into? It's going to take that entire string and it's going to take all the capital letters, which is just one, the capital R, and it's going to turn it into lowercase. So this is all that's going to do. Okay, so let's make sure that that does what we think it does. I'm going to run it. Welcome to the adventure. How do you escape from the leafy forest? Run away. So it prints run away just like before, and then it prints run away with a lowercase r. Let's try something all caps. A, B, C, whoops, C, and then we'll put in some funny characters up here just for fun. What happens when we run this? Okay, so there's our original, all capitals, and then you can see it changes it to lowercase and does that. So when you're learning Python, it's partly like learning a language where you have vocabulary, and learning about the lowercase function is one of the functions that you can apply to a string variable that will modify it. And there's all kinds of stuff you can do, and we're about to do the next one, which is really important. So since we're in an infinite loop, I will simply press the stop button. And now we will do our third step, which is reply underscore list equals. We're going to start from the lowercase version of the reply lower, and we're going to split it into pieces. So there's another function associated with a string, and it's called split, and it splits up the string based on white space, which is space characters. And then, of course, we will print reply underscore list. Now we will be able to see 3 print statements that will show us all 3 stages of our input. So we're going to run this. I would say, run away with a hurry. Okay, so you notice I used capital letters there. So now we're going to see 3 print statements. It's going to be what I just typed in, and then all lowercase, and then the list. And there they are. So run away with a hurry is what I typed. Run away with a hurry is lower cases. That's using the lower function. And then using the split function, we got these words, run away with a hurry. But then, of course, it's an infinite loop, and we're not actually doing anything with that information, so it just asked me the same question again. So I'm going to stop it. And now, this time, we're actually going to do something based on that information. So the joke answer is, the joke for escaping from the forest is you have to say something about leaf, because you're going to leaf the forest. You see, it's a pun. Okay, so we say, if the string leaf, and I can just use lowercase letters because I know it's going to be all lowercase, in reply list. Now this is a tricky line of code, because what it's doing is it's saying, I just took the string leaf here and I placed it down here on this if statement. Then I used the word in, which you remember says, is the thing I'm interested in, that's the word leaf, somewhere in this list. So if the players answered had nothing to do with the word leaf, then this is going to be false. But if I said the word leaf in there somewhere, then this is going to be true. And that's all I need to do to be able to escape from the forest. And of course, the way we get out of an infinite while loop is we use the break command. So that's it. Now let's be complicated and do one more thing, because if we didn't leaf the forest yet, then we have to loop back around. So let's now put in a call to our say_dunno function to tell the player that either that didn't do anything or we didn't understand. Remember, that's a random choice. So we'll say say_dunno. So it's very important to understand that say_dunno only runs if this if statement is false, okay? So let's see how that works in practice. We know that if we break from the while loop, we'll fall through, we'll skip all these comments, and we'll just say, congratulations, you win the game. So we already have a built-in test for whether or not this works properly. So I'm going to run it. How do you escape from the leafy forest? I run away. Okay, so it says, I run away, that's what I entered, and then there's the lowercase version of it, and then it changes it into a list of 3 words, I, run, and away, and notice that away has exclamation marks attached to it. Okay, and then it says, that does not seem to help. So that was false because I didn't use the word leaf. So how about if I say, I will leaf the forest? So I used the word leaf this time. So here's what I said. Here's lowercase, and here's the list. I will leaf the forest. Congratulations, you win the game. Thank you for playing. So it works as desired. Now I'm going to show you a way that this cannot work the way we want it to. And that's as if I get really attached to those exclamation marks. How do you escape from the leafy forest? I give up. Okay. Gosh, I'm afraid I do not know how to do that. Sorry. How about we try again? How do you escape from the leafy forest? I leaf Here's the problem. When I run that, it converts iLeaf to lowercase iLeaf, and then it breaks it into I and then leaf with exclamation marks after it. So we never got rid of those exclamation marks. And that's too bad, because that's not going to be the same thing as just having the word leaf here. So when the if statement runs, leaf in list is not going to be true. It's going to be false, because these exclamation marks change that string. So that's a more advanced topic. I just wanted to point that out. Okay, how do we escape from the leafy forest? iLeaf. Okay, good, that works. And now we're in business. So the only thing I need to do to this while statement right now is I'm going to comment out the print statements that let me see what's going on, because the player doesn't need to see those, and we use them to convince ourselves that everything was working the way we hoped. So now we have an if statement that gets us out of the forest and a say to no, okay? So now that we're 30 minutes in, we're going to do the rest of the code without too much more to learn, because we've already learned all the key stuff. But the next adventure phase is going to be slightly trickier. It's going to be slightly more fun. So we'll do that one, and then we'll be all done for today. And by the way, I want to interrupt myself to say that when this is done, what I'm hoping is that you'll find this interesting and fun, and you will try and write your own adventure. And if you write that adventure on repl.it, then you can simply share it on Slack, for example, and then other people can go and try it out. So this is definitely a participatory plan. We hope that you will participate and everybody can enjoy one another's adventures. Okay, so now we have to say some more stuff about what happens. So I'm going to delete that comment, and I'm just going to make that stuff exist now. So we're going to say print. I'm going to say print. You leave the leafy forest, and you find yourself print walking down a dusty road. Oops. Sleep of 2. So we'll let them read that and pause for 2 seconds, 2.5 seconds. And then we will say, whoops, print. Oh no, up ahead, there is a house. Print. And it seems to be on fire. Sleep 2. Print. There is also a camel and a bucket of water here. Okay, so that's the message that they read in between the first while loop and the second while loop. So let's just make sure that that runs. I run my program. How do you escape from the leafy forest? I leaf the leafy forest, and you find yourself walking down a dusty road, but oh no, up there ahead there's a house, and it seems to be on fire. There's also a camel and a bucket of water here. I think that will read better if I put another blank line in. So we'll assume that that works okay, and now we will do our next and final while loop. Again, while true, so we're going to keep on asking for input from the player. Ask for what the player does. So we say reply equals input. What do you do next? And then as before, we say reply lower equals reply dot lower. And notice that reply underscore lower looks a lot like reply dot lower with parentheses, but this reply refers to the previous variable, and I'm using a method attached to it called lower dot lower, whereas this is just the entire variable name of a brand new variable. Okay. And then I will also say reply underscore list equals reply lower dot split. And now, as a little advanced tip, I'm going to show you something that you could do. you can actually glue these things together in a really simple way. You can say reply underscore list equals input. What do you do next? Question, question, question. Dot lower dot split. Okay, so I'm showing you this as an example of how Python can become more second nature when you become really familiar with it, and you can shorten down 3 lines of code into 1 line of code by tagging on these functions, and they all execute in a series. We're not going to do that today. I just wanted to mention it in passing, that you don't always have to work from 3 lines of code, but you can combine stuff together and make your code more economical. Okay, let's see. Now, what are we going to do? Well, first of all, let's give them a chance to say the right thing. And the right thing in my mind is going to be that they have to say something about the bucket and the word pour, like pouring water, and the house. So if I say, I pour the bucket of water on the house, then I want that to be a success. And that's going to solve the puzzle here, okay? So I'm going to say if bucket in reply list, it's not quite successful yet, but I'm going to put the break statement here, okay? So if the player replies and they use the word bucket, then right now it's going to fall out of the while loop. But it's not done yet because we also want to make sure that they use the word pour. So I say, and pour in reply list, and house in reply list. Just barely fits, huh? Then break. Okay, so what's the logic here? This time we're saying that 3 things have to be true in order for us to get to this break statement. Bucket has to be in the reply, pour has to be in the reply, and house has to be in the reply. Okay? If that's the case, then it will break and will fall out to the next part of the program, which was going to be congratulations, you win. However, perhaps they did not use all 3 of those words. Now we have to deal with that. Suppose they try and do something with the camel. We'll say elif camel in reply list. So the logic here is, if they said anything about the camel, and they didn't say this other stuff here, then they're going to fall through to this else if statement, which is abbreviated elif, and it's going to check for the word camel. And if the word camel is in there, then we're going to have a good response to that. So regardless of what they said about the camel, we're going to say, first print a blank line, and then we're going to say, the camel is not amused. Print. It says, humph. And walks away. So that's what we call an Easter egg. It's something you can discover if you try something, but it turns out to be not the right thing. And then finally, if the person wrote something in their reply to what do you do, and it didn't involve the camel or the correct answer for pouring the bucket of water on the house, then they said something else, and that's an else statement that finishes up our else statement here. And just as before, we will simply say to no. So that calls the say to no function. All right. Let's make sure this runs properly because we've written quite a lot of code. The replies are as before. The bucket's if statement uses and to make sure that 3 words are in the person's reply. And then we have the camel clause, and then we have say to no. So let's see what happens. Starts from the beginning. How do you escape from the leafy forest? I leaf. And now you leave the leafy forest and find yourself walking down a dusty road, but oh no, up ahead there's a house and it seems to be on fire. What do you do next? Okay, I run back to the forest. That does not seem to help. How about we try again? What do you do next? I get on the camel and go for help. The camel is not amused. It says humph and walks away. What do you next? I will pour water on the house. That does not seem to help. Okay, and that's because I didn't use the word bucket, because I have to say bucket also. Pour bucket of water on house. Spell house correctly. Congratulations, you win the game. Thank you for playing. Okay, so everything works as expected. But now you can see that I said something pretty reasonable. I said pour water on the house, and that's really in the spirit of the right answer. So I could create more if statements in here that account for more possible answers that the player might come up with. And that's part of the design of the game for you, the programmer, is to figure out what sorts of things people are likely to say and then create code that will respond to that. But it gets rather involved after a while, so you'll find it an interesting and challenging task to make your game fun and responsive. So we've done this part of the code. The last thing we have to do, according to our outline, is say some more stuff. So let's say print. Let's see. The house is no longer burning. There's a famous musician who wrote a song about a burning house. His name is David Byrne. So let's make a joke for people who are my age and say, David Byrne emerges from the smoldering of the house. He thanks you. And we'll put a little sleep in here just for fun. Let's see, this is a long message to read, so we'll sleep for 4 seconds. And then we'll say print, and congratulations. How many people are here? Well, there's quite a few. Okay, so there's our final message, including the congratulations that we wrote at the beginning. So notice that my approach to this, writing this program, was to write a sketch of it in English, a sketch of how the program was going to go in English, and then to fill it in one piece at a time. And by filling it in little pieces, I can make sure that each new piece works before I go on to write the next one, so that I'm not trying to debug a gigantic adventure. Okay. So I guess since we made one more change to the code, we should walk it all the way through one last time to make sure that we're happy with it. So we say run. I'm going to stop it, and I'm going to turn on these sleeps again by uncommenting them. So I'll get the full user experience by running this program one last time. Okay, we don't want to put those print statements back in though. All the sleeps are there. Everything looks good. Here we go. Welcome to the adventure. We will start in 3, 2, 1. Begin. You are walking through a vast forest of leafy trees. You have been wandering lost for days. How do you escape the leafy forest? Let's see. I ride the camel out. That does not seem to help. How about we try again? How do you escape from the leafy forest? I leaf the leafy forest. You leaf the leafy forest and you find yourself walking down a dusty road. But oh no, up ahead there is a house and it seems to be on fire. There is also a camel and a bucket of water here. I pour the bucket of water on the camel. That does not seem to help. Oh, interesting. Okay, so here's a question for you. Here I mentioned camel, but it does not say to me the camel is not amused. It doesn't say the camel is not amused. It says humph and walks away. Why didn't that happen? Because I used the word camel. I'll allow you to puzzle this over for a second. So for those of you who guessed, congratulations. And if you would like to just simply enjoy the show, the word camel has a period after it, and that got stuck to it. So when that list got created, it wasn't the word camel, it was the word camel period. So let's try this again without the period and see if this works this time to get the camel message. I pour the bucket of water on the camel. and I hit return. And now it says the camel is not amused. It says humph and walks away. Okay, so that's a common debugging technique, is to try and figure out how something works by pretending that I am the computer and how will I interpret what's going on. Okay, so the camel has walked away. Let's just pour the bucket of water on the house. Oh, I misspelled house. Pour the bucket of water on the house, spelled correctly. The house is no longer burning. David Byrne emerges from the smoldering timbers of the house, which I also spelled wrong. He thanks you. Congratulations, you win the game. Okay, so let's fix the spelling of house. Nobody told me that I spelled house wrong. And now we're all done. So at this time, I would like to ask, what are your questions? And I have some comments down here on advanced ideas and how you could treat this as an assignment. So if you have any questions, I'm actually not looking at the chat, so you'd have to turn on your microphone and say, I have a question. For 10 bonus points. I'll let you ponder this for a moment.
I have a question.
Yeah, let's hear it.
So why did you do blank print instead of /n?
Oh, you're asking why did I do print like this instead of print /n? Is that what your question is?
Yeah.
Okay, so print /n means print the line feed character, and print with nothing means don't print anything, but throw in a line feed character. So it's exactly the same end result. Okay, they would both do exactly the same thing. But I used a simpler version because I like to have less clutter in my code, and I happen to know that if I use print without any arguments, it will just print a return. That's why, no difference. Okay, so let's see, you can interrupt me for the next few seconds. Oh, well, we did this in 45 minutes, so we went kind of fast today. So let's see, I will put the URL on Slack, but this is repl.it and then my name and then the word adventure, so you can get to this code. You could even run the game. Your assignment is, should you choose to accept it, since it's a club, it's not like homework that you have to do, but it is, I'm using the word assignment to make it feel like, aha, something official to do. Write an adventure and share it with others. You can share it with your coach and with your fellow players. Let's see. You can use the structure that we created up above. This is the one puzzle per room style, right? What do you do? And then you can post the URL of your solution on Slack if you like. Okay, as I mentioned before, there's two advanced ideas. One of them is to include an inventory list, so you can say something like, get paperclip, and the program recognizes that and it adds to a list of things that you're carrying, and then you can use them later. The other thing you can do is you can try and figure out, and this is a tricky problem, you can try and figure out how once you leave one room or one area, you can come back to it. So I tried to go back to the leafy forest, but the program doesn't know how to let me do that yet. So see if you can figure out how to navigate around in places that you've already been to. That's one of the key features of a more advanced adventure game. It's out of scope of what we're doing here. So as always, I'm constantly checking Slack. If you just talk to me on Slack, if you have more questions or ideas, or you have an adventure you want to share, then I'm really happy to see it. Yeah.